But we've also been studying things a lot closer to home, including the giant planet in our solar system, Jupiter. So Jupiter is something we can see with our own eyes, just walking out on a dark night, moonless night mostly. And you can see this big, beautiful planet with your own eyes. We have spacecraft currently orbiting Jupiter and taking absolutely amazing images in details that we aren't able to see with most telescopes. So what you're seeing here are some images that were actually taken with ground-based telescopes in the top left. These are at two different wavelengths. One is at visible light on the left. The reddish one is actually at infrared light, so something that we are studying with the James Webb Space Telescope. And then the large image is actually from the Juno mission, showing you the beautiful structure of the atmosphere of Jupiter and highlighting the great red spot. Well, we were able to look at Jupiter with the James Webb Space Telescope and study it in beautiful amounts of detail. Not only do we see all that fantastic structure in the atmosphere with the James Webb Space Telescope with our resolution, and surprisingly, with the extreme amount of sensitivity of JWST, Jupiter wasn't too bright to actually look at. In fact, we were able to see things that we haven't been able to study in a lot of detail, especially with remote telescopes or telescopes on Earth or those such as the Hubble Space Telescope before. What we're seeing now are rings that are being totally illuminated and lit up in ways that we can now see readily with the James Webb Space Telescope. The smaller moons that are harder to see with our naked eye, and even some of the aurora of this giant planet. The great red spot looks bright white in this image, and that's just because it's emitting at extreme temperatures that are quite hot and showing us the different amount of radiation coming from that particular storm. And the fun part about this image is all these little dots in the background. These are all actually photobombing galaxies in the background of this image, and something that we don't see very routinely with a lot of ground-based telescopes when we look at planets in our solar system, just because most of them are blocked from a lot of light that we can't see. And of course, you can blow this image up and use different filters of wavelength and understand all the different things and dynamics that are happening. But in the interest of time, I'm going to move on.